All right, so we're here for an AC tune-up today. When I do AC tune-ups, I always like to start in the house at the thermostat. What a lot of people don't realize about air conditioners is how they work and what they're supposed to do. A lot of people think like when you're driving in your car, the lower you turn it, the colder it gets. That's actually not how ACs work in a house. The whole purpose of the air conditioner is to just reduce the temperature by 20 degrees. So inside we can see here, they've got a Google Nest. The current temperature is 71 degrees. So I'm going to lower it about 5 degrees. That'll give me time to do what I need to do. So it's 71 inside. We're going to turn the AC on. And so what we're looking for coming out of the vents should be 51 degrees. Anywhere really between 18 and 22 degree drop is what we're looking for. So I always start by turning the system on and checking the temperature. It tells me a lot of things about your system, how it's working, any inefficiencies we have, and taking these temperatures all throughout the house. If one vent is putting out different temperature than other vents, it could identify a problem with the ductwork, any number of different things. So always starting by taking temperatures everywhere. All right, so we're outside at the condenser. This is where most of the work is going to happen for an AC maintenance. This condenser, a lot of people understand this to be your air conditioner, but it's actually just half of it. The other half of your air conditioner lives at your furnace. That's the part that exchanges heat for cold. And then out here, the whole purpose of this, it's a really simple design. You've got a high voltage fan motor on top and then a compressor motor inside. And what this does is the fan comes on and it draws air in from the sides all the way around through these coils. These coils, they look like kind of like a radiator on your car. So it's really important that they be clean so that they can breathe and do their job in cooling the refrigerant. But it just draws air in from the sides and it exhausts it out the top. So the heat that you feel coming off the top of these is the heat that it took from inside the home. It exchanged heat for cold. So this is just the exhaust of your system. So the first thing I always like to check, you should have a disconnect within 10 feet of this system. This is the electrical disconnect. So I always pull this. You've got a couple of fuses on here, and then your terminals for connection. I never like to see dry terminals on here, so I always put a little dielectric grease on here. It just helps for a better connection. The other thing I like to do is inspect the disconnect box. Electrical and dust never get along and always cause a problem. So behind here, this is where your high voltage comes in. Got 240 volts coming into this. And it's really important to check all these lugs and make sure that they're totally tight. Any loose wires will cause shorting and could damage your system. So it's good that we did this. Checking all these electrical connections here. Every one of them was loose. In fact, one of them was completely disconnected. And so what I did is I turned the power off at the breaker and I came in and I retightened everything down. So we're good to go now. So now we can close that up. And that's not something that just sort of happens on its own. Um, that's something that comes from whoever installed this. A lot of times what I find is people save a little money and go with someone cheaper to do the install. But then you find things like this, and that could have easily arced, caused a fire, any number of different things. So now what we're going to do is we're going to open this up so that we can clean everything. And once I get it opened, I'll show you inside. It's a very simple machine. And I'll show you that process as we go. This is another great tool. Obviously, I can't get these screws back here, but Milwaukee's always got a solution. All right, so over here, this is your data plate. It tells you everything you need to know about the system, everything that a tech will use when they're testing different things. So I always want to inspect these, make sure we don't have pitting, burn marks, arcing. Over time, where those brass lugs connect, there's an arc every time that happens. And on these older units, that arc can create a pit and a really loose connection that can cause fires, can cause any number of things. So it's really important to check those out. So now I've got the unit opened up. The first thing I like to inspect is this fan motor. When these things fail, this fan does two things. It pulls all the air through the coils, but it also helps protect and keep that compressor motor cool, keeps it from overheating. And so you never want your fan motor to fail. Beyond just not getting cool, you can damage that motor. That motor is generally about $1,000 per ton of system, and then usually a couple thousand to replace it. So it's the most expensive part of your air conditioner system. So we always want to protect that and make sure it's in good shape. So this motor, what I'm looking for, if you want to come over and see, on the motor, I'm looking all around the edges for any oil coming out, also around the shaft. You also want to make sure the shaft isn't loose. And so this one looks great. You'll see lots of oxidation on here. It's all superficial. It means nothing. But when oil starts leaking out around the edges or around the shaft, that's a good indication that this motor is on its way out. So inside these units, people are always pretty blown away at how simple they are. You can see two layers of coils going all the way around, and these fins, because the air comes in from the outside and up through the top, the best way to clean these is from the inside out. You'll get lots of spiders, lots of black widows that live inside these things. And I love this cleaner. It just breaks down everything that clogs these. So we tested the capacitor. Everything looked good there. Now we're going to check the health of the compressor motor and this fan motor. And we do that by testing the amperage. So that data plate on the outside of the unit that tells you all the numbers, all the different things to look for, that gives us the numbers that we'll be looking for right here. So the first number is LRA, stands for lock rotor amps. So we're going to be testing the amp draw that this compressor draws when it initially starts up. We're going to test the amps as it's running, and then we're going to test the fan as it's running. And there's a certain number we don't want to exceed. If we do, it tells you that motor is getting ready to go. So we'll test those now. So this is the furnace inside the house, and it's a downdraft furnace. And at the bottom of the furnace, this is actually the other half of your air conditioner. So this is the part that exchanges heat for cold, and it's got a primary drain line and a secondary drain line. These units produce a lot of condensation, and that condensation needs to be able to drain out. And so these lines, it's really important to check them, make sure they're clear. If the lines get clogged up for any reason, that condensation will then get trapped in your evaporator coil here. And what can easily happen is that it can freeze over, and then your system stops cooling.